Welcome to FullStackDev. Today we explore 25 tips to boost Node.js app performance. Let's make your apps faster. Learn practical techniques to optimize speed and efficiency. They're easy to apply in your projects. See real-world examples that show how to improve your back-end code. Get ready to level up. Join us to build blazing fast Node.js applications. Let's dive in and start coding smarter. Node.js is single-threaded. Use clustering to utilize multiple CPU cores. It boosts performance for heavy workloads. For example, a web server can fork worker processes to handle requests in parallel. This reduces response time. Tip: use the cluster module to scale your app across CPU cores. It's simple and effective. Async code is key in Node.js. Avoid blocking the event loop with heavy synchronous tasks. Use promises or async await. For example, read files asynchronously with fs promises read file. It keeps your app responsive during I/O operations. Tip: always use async methods for I/O tasks. It prevents slowdowns and improves performance. Caching stores frequent data to reduce server load. Use tools like Redis to cache API responses or database queries. For example, cache a product list with Redis. It serves data faster than querying the database each time. Tip: cache non-sensitive data to speed up responses. Set expiration times for freshness. Profiling identifies slow code. Use tools like Node.js built-in profiler or Clinic.js to spot performance bottlenecks. For example, Clinic.js can show a CPU spike in a loop. Fix it to improve your app speed. Tip: regularly profile your code. It helps you catch issues early and keep performance high. Streams process large data efficiently in chunks. They reduce memory usage for tasks like file processing. For example, use fs create read stream to process a large CSV file. It handles data chunk by chunked byte. Tip: use streams for big files or data transfers. It keeps your app memory efficient. Compressing HTTP responses reduces data sent over the network, speeding up client-side rendering. Use middleware like compression in Express. For example, enable gSIP compression in Express to shrink JSON responses. It lowers bandwidth usage and improves load times. Tip: always compress text-based responses like JSON or HTML. It boosts performance for web apps. Worker threads run CPU-intensive tasks in parallel, keeping the event loop free. Use Node.js worker threads module for this. For example, offload image processing to a worker thread. It prevents blocking the main thread for smooth performance. Tip: use worker threads for tasks like encryption or image resizing to maintain responsiveness. Efficient database queries reduce latency. Use indexing and selective queries to fetch only needed data in Node.js apps. For example, add indexes to MongoDB collections for faster searches. Avoid fetching unnecessary fields to save time. Tip: always index frequently queried fields and select only required data to boost performance. Load balancing distributes traffic across servers, preventing overload. Use tools like Nginx or Node.js PM2 for balancing data. For example, configure Nginx to route requests to multiple Node.js instances. It ensures even load distribution. Tip: use a load balancer to handle high traffic and improve app reliability. Minifying JavaScript removes unnecessary characters, reducing file size and improving load times. Use tools like Uglifies or Terser. For example, minify your Node.js backend scripts with Terser to speed up module loading in production. Tip: Pyte. Minify all production JavaScript files to optimize performance and reduce server load. Connection pooling reuses database connections, reducing overhead. Use libraries like pgpool for PostgreSQL or Mongoose for MongoDB. For example, set up a connection pool in PostgreSQL to handle multiple queries efficiently without opening new connections. Tip: Configure connection pooling to manage high traffic and reduce database latency. HTTP2 improves performance with multiplexing and header compression. Use Node.js HTTP 2 module for faster client-server communication. For example, serve your Express app over HTTP2 to reduce latency by sending multiple requests over one connection. Tip: Pyte. Enable HTTP2 in production to speed up data transfer and improve user experience. Lazy loading delays module imports until needed, reducing initial load time. Use dynamic imports in Node.js for efficiency. For example, dynamically import a heavy module like Sharp for image processing only when required. Tip: Pyte. Use lazy loading for non-critical modules to speed up app startup. Monitoring tracks performance metrics to identify issues. Use tools like Prometheus or New Relic for real-time insights. For example, monitor request latency with Prometheus to detect slow endpoints and optimize them. Tip: Pyte. Set up monitoring to catch performance issues early and ensure app reliability. Catching headers tell browsers to store static assets, reducing server requests. Set cache control headers in Node.js. For example, use Express to set max ager 31,536,000 for static files, like images, to cache them for a year. Tip: Pyte. Use caching headers for static assets to improve client-side performance. Excessive middleware in Express can slow down requests. Use only necessary middleware to optimize performance. For example, skip logging middleware in production for non-critical routes to reduce processing time. Tip: Pyte. Review and remove unused middleware to speed up request handling. Efficient JSON parsing reduces CPU usage. Use FastJSON Stringify for schema-based serialization to boost performance. For example, apply FastJSON Stringify to API responses with fixed schemas to serialize data faster. Tip: Pyte. Use optimized JSON libraries for high-throughput APIs to save processing time. Native modules written in CIT run faster than JavaScript. Use them for computationally intensive tasks in Node.js. For example, use a native module like bcrypt for password hashing to improve performance over JavaScript versions. Tip: Pyte. Replace slow JavaScript functions with native modules for critical tasks. Batching IP requests combines multiple calls into one, reducing network overhead. Implement batch endpoints in your API. For example, combine multiple user data queries into a single GraphQL query to minimize round trips. Tip: Pyte. Batch requests in high-traffic APIs to improve efficiency and reduce latency. Code splitting divides your app into smaller chunks, loading only what's needed. Use dynamic imports for client-side bundles. For example, split a large Node.js app by lazily importing routes with dynamic imports to reduce initial load. Tip: Split code for faster startup and better resource usage in production. Logging can slow down apps if not optimized. Use libraries like Pinot for fast, low-overhead logging in Node.js. For example, replace console.log with Pinot to log JSON, structured data efficiently in production environments. Tip: use asynchronous logging libraries to reduce performance overhead in high-traffic apps. Memory leaks can degrade performance over time. Monitor memory usage and fix leaks using tools like Node.js heap snapshots. For example, use heap dump to capture snapshots and analyze unreleased objects in long-running apps. Tips: regularly check for memory leaks to ensure your app remains stable and efficient. Fast frameworks like Fastify handle requests more efficiently than heavier ones. They improve Node.js app performance. For example, switch from Express to Fastify for faster routing and lower overhead in high-traffic APIs. Tip: choose lightweight frameworks like Fastify to boost request processing speed. The event loop is Node.js's core. Avoid blocking it with heavy tasks. Use setImmediate or process next tick for non-blocking code. For example, use setImmediate to defer CPU-heavy tasks, keeping the event loop free for other operations. Tip: prioritize event loop responsiveness by offloading heavy tasks to async methods. In-memory caching stores data in RAM for fast access. Use libraries like NodeCache for lightweight caching in Node.js. For example, cache user sessions in NodeCache to avoid repeated database queries for authentication. Tip: use in-memory caching for frequently accessed data to reduce latency. That's 25 tips to boost your Node.js apps. Apply them to make your projects faster and more efficient. Experiment with these techniques in your code. Small changes can lead to big performance gains. Subscribe for more coding tips and share your favorite optimization tricks in the comments. Thanks for watching FullStackDev. Keep coding smarter and building blazing fast apps.